It's impossible to miss, right? We are living through an absolutely incredible AI revolution. These models can create breathtaking art, they can write code, they're even passing some of the toughest exams out there. But, as amazing as all that is, there's still this huge gap between the tools we have today and what you'd call true artificial general intelligence, or AGI. To get from here to there, we have to cross a massive chasm. So let's map out what's waiting for us on the other side and figure out what's missing from the bridge we need to build to get there. This quote right here, it just hits the nail on the head. We've definitely moved the needle, a lot. But we're not on some smooth, straight highway to AGI. Nope. There are major structural gaps we have to figure out how to bridge first. So that's our job in this explainer, to map out exactly what those gaps are, and then take a look at the blueprint researchers are putting together to finally build that bridge. So first off, how did we even get here? Well, the success of AI today is really built on a pretty simple but incredibly powerful idea. You take these massive neural networks, especially architectures like the transformer, and you train them on just colossal amounts of data scraped from the internet. That's the engine behind this whole boom. And the results are, well, they're amazing pattern matchers. They are fantastic at predicting the next word in a sentence or the next pixel in an image. But, and this is the big but, they're also fundamentally static. Once they're trained, their knowledge is basically flash frozen. It's like a photograph of the internet from a year ago. They're associative, meaning they know coffee and cup often go together, but they have no clue why. And that makes them brittle. You ask a question just a little bit outside their training data and the whole illusion can just shatter. And that brings us to the chasm. I want you to picture it like this. On one side, right where we are now, we've got our super powerful AI. And way over on the other side is true AGI. In between is this deep, wide canyon that represents everything our current systems can't do. Lucky for us, the research doesn't just point out the canyon, it gives us a map and even a blueprint for the bridge we're going to need. All right, so let's get specific. If you're going to build a bridge, you need to know what the support pillars are made of, right? What are the absolute core components that today's AI just plain doesn't have? The research points to a whole laundry list of missing pieces. Things like online continual learning. That's just the ability to learn on the fly without having to be completely retrained from scratch. Or motivated control, which basically means having your own sense of curiosity. It's a long list, for sure, but all these missing pieces really fall into two major categories, and these are the biggest gaps in our bridge. Okay, first up, the absolute fundamentals. How an intelligent system takes in new information and actually holds on to it. This is all about the flow of knowledge, how it gets acquired, stored, and then pulled back out when it's needed. And the difference here is just stark. Current models, they're trained in these giant one-time batches, and then their core knowledge is locked in. It's like they graduate and never learn anything new. And AGI, on the other hand, well, it has to be like a human. It has to learn constantly from every new experience, updating its understanding of the world in real time, and crucially, without forgetting everything it already knows. It needs to be driven by its own curiosity to explore and learn. And then you've got memory. Today's AI has a really limited short-term memory. It's called a context window. For everything else, it relies on these external databases that are kind of like clumsy digital filing cabinets. I mean, imagine if your entire memory was just the last 10 minutes of conversation. That's kind of what it's like. A real AGI needs a rich, integrated long-term memory, a place where it can store experiences, concepts, and skills, and then pull them out reliably whenever it needs them. All right, let's move on to our second major gap. This one is all about the internal world of an AGI. See, it's not just about absorbing information. It's about what the system does with that information. How does it think? How does it prioritize? How does it decide to act on its own? This is what some call the difference between cold and hot cognition. Current AI is cold. You give it an objective, it solves it. It's basically a superpowered calculator. It doesn't have any internal drives, no curiosity, no wants or preferences. A true AGI would need hot control, its own motivations, its own values that actually guide what it pays attention to and what it decides to think about. Now, this one is a little subtle, but it's a massive difference. Today's AI is an expert at pattern matching. It knows from reading billions of web pages that the word bacon often shows up near the word eggs, but it doesn't understand why. It has no idea that cooking bacon causes a smell or that cracking an egg is the cause of having yolk in a pan. An AGI needs to build a true model of cause and effect to really understand the world.
And finally, attention. In the models we have today, attention is basically a mathematical trick that helps figure out which words in a sentence are most related to each other. It's reactive, but human attention is proactive. We choose what to focus on based on our goals. And AGI needs to be able to do that too, to consciously direct its own mental resources to whatever is most important for the task at hand.
Okay, so we've mapped the chasm. We know what's missing. And the great news is that researchers aren't just standing around pointing out the problems, they're actively designing the solutions. So now let's look at the actual blueprint for building this bridge to AGI. So the proposed path forward, it looks less like one single giant brain and a lot more like a team of specialists working together. The big idea is to build a hybrid system. It would combine the creative pattern matching of today's models with something like a logical reasoner, a symbolic system that actually understands rules. And then overseeing the whole thing, you'd have a meta-controller. Think of it like the project manager for the AI's mind, telling it what to focus on and when. It's about building a system with different specialized parts that cooperate, not just one giant static network.
And you know what? These aren't just abstract theories on a whiteboard. The blueprint comes with concrete experiments we can actually run today. We can build benchmarks that really test an AI's ability to learn over a lifetime, we can reward it for being curious, and we can even test its self-awareness by seeing if it knows when it needs to ask for help. This is how we'll measure real, tangible progress.
And this is the really crucial part. Building this bridge can't be some secret race run by a single company. The proposal is a call for a massive, open, collaborative effort, kind of like the early days of the internet. It's about sharing the tools, sharing the data, and sharing the frameworks so that the entire global community can help build and test every single piece of this bridge together.
So, the single most important thing to take away from all this is probably this. The future of AI isn't just about making today's models bigger. It's about making them fundamentally smarter and more integrated. It's about building a hybrid architecture that combines the incredible scale we've already achieved with all those missing pieces of the AGI puzzle. And all of this leaves us with a final and pretty profound question. The goal here isn't just to build a better tool. It's to architect a system that learns, reasons, and acts in ways that are far more like us. So, if we actually succeed, if we manage to build this bridge, what kind of intelligence, what kind of mind will be waiting for us on the other side?